So, right, so the voxel space render is kind of a cool little thing from the early 90s. Basically, an early stab at 3D. It's a two-dimensional solution to the problem of drawing something in 3 dimensions. Essentially, okay, right. So the original implementation iterated horizontally across the screen. So for every column of pixels, there's kind of a direction that we're looking at, and that's based on, and so again, this is the original implementation. It's going to be basically, there's 2 points out in space, and that's kind of out here, and that's how we get our depth foreshortening, so it's like starting from a single point and going out in a sort of a frustrum almost. So they took 2 points and kind of interpolated across to get a sample on this height map. There's some little bit of translation logic to give me a height value with respect to the horizon. So horizon is this essentially a vertical scale factor almost. It's slightly more complicated than that, but not much. So basically, yeah. So as I go out for each vertical strip of pixels, I start at a y value of 0, right? And I'm iterating across, iterating across, iterating across. Now I hit the map, I've got some height value to work with, right? So I start at 0 and I go up now to some given y, and that's determined by a height map. In this particular case, we're looking at number 15 here. So I go out and I hit the map. Now I have a y value, right? And so that's going to replace my buffered y value that is the maximum y I've ever seen, basically, for this strip. They call it a y buffer in the implementation I referred to. So as I go across more and more and more, I know that I'm never going to be drawing below that y value. And basically, as I go across more and more, that keeps going up and up and up and up, right? Until here, I know that I'll never be drawing below this point all the way across. And so what that does is basically prevents you from overdrawing a bunch, creates some artifacts on edges, I guess, when you hit from a 0 value and you go to your height. But that's just going to happen. The alternative would be to go from back to front and just draw in every pixel and just accept all that overdraw, like the painter's algorithm, basically. So it's just keep drawing from back to front. This is actually pretty quick, though. We're looking at 3 milliseconds for this thing. Now, where it gets expensive is off map traversal, like, because it will just run out to the maximum distance, whatever the maximum distance is. So if I bring the maximum distance down, it seems to scale about 1,000 units of, when I'm in this kind of position here, about 1,000 units of distance maps to about a millisecond. So my implementation calculates the frustrum a little bit differently, and there's some other logic to offset the view position. But one of the cool things that allows for is adjustment of the FOV. So if I like something wider versus something thinner, or if you want to screw around, you can have it wrap around. And basically what that refers to is my field of view becomes greater than 360 degrees. It's kind of dumb, but And that looks shitty, stuttery. But yeah, so anyway, so we're looking now down closer to the thing. I'm gonna set the horizon so that it looks more reasonable. What are we doing wrong here? Yeah, so I've been screwing around with the parameters a lot. That's kind of a, we'll bring the height scale down. Horizon back up. FOV back somewhere reasonable. Oh, this is gonna be, okay, let's do it this way, yeah. So now this side-to-side offset is basically, I've got direction that comes from this angle, right? And so as I spin around, I'm changing the angle. Now I just do rotation matrix calculated off of that in radians. And so then that direction vector just goes out into space in front of the thing. And then I can take the up vector, which is just one unit on the y value, or on the y, and then I can take the cross product of those two things and get a vector that goes to my right. So that gives me this ability to offset each strip's view position, right? So I'm mapping 0 to screen width to -1 to 1 on the thing here. And that's like an easy way to do FOV, an easy way to do this side-to-side offset. That's really all I'm using it for right now. The yeah, anyway, so it goes out in this implementation, right? So I'm using that same -1 to 1 to adjust my angle based on this FOV scalar value. So angle varies more or less from side to side as I change that slider. So yeah, the kind of idea here is like, I've got this other program that does two-dimensional erosion, and it computes a height map, and then it's looking at like particles that come down and land on the surface. So it's like, yeah, it's particle based, and these little river type things start to happen, and I'm really quite interested to see that happen in real time on this. And then I have another compute shader that's going to generate me a color map. I've got to write that yet, but and then also potentially shadowing based on that as well. So essentially what I'll be producing is this height piece, but I won't have a corresponding color piece, right? So I've got to do that myself. These shadows are all pre-computed with the data that I found. If you look up voxelspace, there's a very good explanation of the algorithm. But so as time goes on, more and more, you start to see these rivulets type of thing form. So my thinking is like, okay, every however long, I'll go ahead and be updating this information on the GPU so that it updates on this view. And then we get the updated shadows and whatever coloring I'm going to do with that. The logic for the erosion stuff is actually looking at particles that fall down, and then it looks at the local slope. So that's kind of like neighborhood. Yeah, looking at the neighborhood to be like, you know, these are places where it'll accelerate downhill, basically. There's good videos explaining that algorithm in a lot more detail, but yeah, you can kind of start to see now much more pronounced effects, and I'm really kind of excited to visualize that in this other viewer. So like, yeah, that starts to look actually kind of almost like something that's I don't know, naturally formed. So that's doing something called hydraulic erosion, and that's really not that complicated. It's not a lot of lines to implement it, and I've got it implemented in this other project as a way to you know, just generate manipulated height map. So, yeah, if I close this out, change which map, and I should set up a picker for this, but if I change which map it refers to, and then don't do that, do this instead, or try this. I should do something that doesn't involve rebuilding it to change which texture it refers to or which image file it refers to, but you know, that's just where it is right now. And so we've got a different height map that's loaded along with its corresponding color map. So you can kind of see where maybe there's some cool stuff you can do with this. It's very you know, I say very quick, but it's not that slow. It's all done in a compute shader, and kind of a cool idea I had for depth fog. Let's go ahead and set this back. Set this like, yeah. So the way that I'm doing depth fog, right? It's not what you might think initially, right? So instead of blending colors here, I'm actually using the graphics API. So I was setting the clear color with mGUI color picker, and then I'm setting the alpha channel of the render texture based on some distance and then some scale value on top of that. So you can kind of imagine how that, you know, when I go to just put that texture on the screen over the clear color, I'm getting these types of effects. That's just a simple way to implement that. And you could just as easily blend your color samples, but yeah, that's the way I'm doing it. So going out into the map and then setting the FOV so that it's kind of wrapping around. It's kind of interesting because you're actually seeing backwards and forwards. So as you move around, you're actually seeing things recede behind you and then simultaneously come up in front of you. That's a little weird. And you can have that wrap around multiple times if you change the settings to express that. But yeah, this is kind of just a neat little thing. I put it together, I guess, Saturday afternoon I kind of started, and then, yeah, I was having a lot of issues with unsigned integers when I was trying to implement it at first. I was doing that because that's what the texture data is, and I was going to work with that directly, but I ended up just saying screw it, and I'm doing all the math in floating point now, and it just works. I literally changed 2 lines, you know, 2 variable declarations to be floats instead of unsigned integers, and that made my previous work just work, which I felt pretty good about. But anyway. Be looking to try and get that other part done at some point. And I think, I don't know, maybe this might be kind of dumb, but think about doing the same thing reversed to do a to do clouds, maybe something. Anyway, the next big thing I want to try and do is minimap, right? So one of those is okay, so my thinking is probably just an orthographic camera kind of, if you could go back to the initial state here, kind of something along these lines, but just like tug it up in the corner. Probably a second render pass to just draw over everything here. I'll think a little bit about how I want to do that, but the general idea is not super difficult. I saw another implementation. Let's see if I can pull this up really quick. here we go. So kind of idea being like you could do something up in the corner here. This is somebody else's implementation. But yeah, so they've got it mashed out to a circle, and I'm thinking also probably adjust the height value at the player location to reflect the player's height. That's probably a nice little extension beyond that, what they have here. And then, yeah, again, so separate shader to do coloration on the map based on whatever's going on there. I'm not exactly sure how the tilt is being done. I gotta look at the implementation on that. Anyway, so, you know, progress, something going on anyway.